So let's continue now with the next presenters. This is also a presentation shared by two presenters. On the one hand, we have Michael Grimm from laser manufacturer 3 Micromax, and then we have Lorenzo Cerasti. He was a product manager with Applied Materials, leading semiconductor manufacturer and also strong in PV equipment. The two of them will talk about high throughput shingling equipment for various applications. We are very much looking forward to your presentation.
So thanks a lot, Mr. Chairman. Just a second. Okay. So I hope, can you see the slides already?
Yes, all good.
Okay, so yeah, thank you. Yeah, as mentioned, this will be a joint talk between 3D Micromax and Applied Materials mainly. And the focus here is on high throughput shingling equipment for various applications. And this is also in close connection to the talk Tuka give. And this work presented here is only performed within the HighLite project. Just a short overview, one slide to highlight. Probably if you have missed the session yesterday, then of course some points about the 3D Micromax and the tool, the same for Applied Materials and their equipment solution for shingling, cutting and assembling. And we also present some very first results within the project. As you might know, here again, some facts about the HighLite. So HighLite is focused on developing novel equipment and processes for premium modules, and this for tailored various applications such as building integrated PV, vehicle integrated PV, and BLPV. And we are approaching here new tech processes and techniques to move them the next step forward. And this talk will mainly address here novel cutting techniques, shingling assembly. And this, of course, results in further work, which is also done within the project in the module manufacturing. It's not the main part of this talk, but there will be a first result from the group working on this point here. So let me introduce shortly 3D Micromax. So we are leading a specialist in laser micromachining, and we're developing processes and production equipment for and machine solutions for various high-tech markets such as photovoltaic, semiconductor, display industry, and many others. And the customers can address us, and we develop together with them process and product development from R&D level up to high volume production. And we are enabling, and in this way, the laser as a tool for micro machining as a use for new devices. And of course, we support production of our customers with a strong service. So the company was founded in 2002. We have 180 employees at the moment, more or less. We are based in Chemnitz in Germany and have some overseas branches also. We have up to now more than 600 tool installations worldwide, and in these 600 there are more than 100 in the PV industry working on 24/7 production for the PV. So as you might know, if you go to the transfer from full to half cells, this is on the way. You have to cut cells, and the next step is go to shingling or cut the cells in many stripes to have this shingling approach in the module design. And there's basically a standard process called scribe and break, but our approach is a bit different. We're using thermal laser separation. So it's indicated here how it works. So we make a very short initial starting point by a laser. It's an ablative process here, very short, 100 or a few hundred microns only. And then in the second process step, immediately after this, we have a combination of lasers and a cooling source, and this initiates stress in the material, and you can guide a crack through the material, and this is a very smooth process. You can see the difference here between scribe and break on the left-hand side with the very deep laser groove here. Leads to some chipping in the material, and you get a very rough surface, while our approach, this thermal laser separation, leads to a very smooth edge. You have no chipping. You see here you can even cut through the metallization here on the rear side of the cell. And this smooth surface is a perfect starting point for repassivation approaches, which are very interesting. If you cut cells in stripes, and this is also a point which is under development within the project. And there's another point besides this smooth surface. Due to the low damage, you also have a very good mechanical properties still after the TLS. You see here numbers for the laser scribe and cleaving, laser scribe and break, and this leads to a mechanical or to a reduction of the mechanical stability. From the full cell, you have a certain loss in mechanical stability on cell level and also on module level. And this is not the case if you use CLS. So there's the mechanical properties remain the same as the full cell springs. So this is also a big advantage and a good fact for long-term stability of the modules you produce with TLS cutted cells. So we have on the market a lot of tools doing this half cell cut, and now we're going within here the project. The next step, we're developing a tool which is able to cut or to make multiple cuts up to 5 cuts, which leads then to 6 stripes out of one cell. And here is the tool concept, which is actually under development. We have a circulating chuck system with 22 carriers. The format and the pattern adjustment are flexible due to the flexible chuck design. And we also have a big flexibility in the process positions. So we can run from 1 cut, which leads to half cells, up to 5 cuts, which leads to 6 cell stripes. And this is possible with a very high throughput, up to 6,400 wafers per hour. So wafer recognition is done by camera, and the scanner, the initial stripe is here by a scanner, which is also important to achieve this high throughput. Process velocity itself, it's up to 500 millimeters per second. You see here the tool design. The tool is actually under construction and will be available this autumn for demonstration and applications. So you're all very welcome to visit us in this autumn or send us material, which will then be processed by here on our side to support you and your business. Of course, if you have tools with such a high throughput, you need also a high throughput automation system. This is sketched here. We have a load system, an unload system. I should mention that we have designed the tool to a wafer format up to M12. So this is also then flexible for future needs. So, okay, so as a short summary here, so we are developing in the project this high-throughput shingling tool. We will set up a demonstrator here. It comes very flexible in the cut design with a very high throughput. The tool will be available as a standalone system for box-to-box processing or as a flexible process unit for integration in other shingling assembling tools, such as AMAX Sonetto solution or others. And this is the point where I want to hand over the presentation to my colleague in the project, to Lorenzo, and he will introduce and present the applied materials part.
Thank you, Michael. Let me briefly introduce my company. So Applied Materials, it's a leading company in the semiconductor and display equipment field with nearly $15 billion of revenue, of which more than 2 spent on R&D and 22,000 employees in 18 countries. Bacini is the solar division of Applied and has more than 50 years of expertise in screen printing manufacturing tools, and since 6 years is developing and improving shingling equipment. Next, please. Thank you. We are shingling pioneers, and we developed the patented solution for this process. Our tools are equipped with advanced metrology, have high throughput, and are capable to handle thin wafers up to 150 microns with minimum breakage. Next, please. So first of all, our tool is capable to work in 2 different configurations. Loading the full cells and perform the laser scribing in line, or we can load the precut shingles in cassette stacks with an offline laser. As Michael said before, we are working with 3D Micromax to implement in our process flow also the TLS. And anyway, at the state of art, we are capable to perform a scribing within 50 microns of precision, accurate morphology, and repeatability, as you can see here. Next, please. In terms of printing capabilities, we can reach very good aspect ratio, even with a very low amount of ECA. We have been able to reach 10 milligrams of paste deposited, which is crucial for cost saving. In terms of precision, we can print the pads or continuous lines in a range of 50 microns, which is a key to enable overlaps between shingles in the range of 0.5 millimeters. Next, please. Okay, thank you. The assembler can align shingles with a precision of 150 microns, and we have been able to reach overlap of 0.5 millimeters, as said before. One of our key features is the flexibility on the string length, and this is particularly important for BIPV or VIPV, or if you need to manage different modules layup. Next, please. Okay, another key point of our architecture is what we call the integrated ECA busing. So first of all, we use ECA glue to attach the ribbon at the beginning and at the end of the string instead of traditional soldering. This allows to reduce the temperature, which is critical for heterojunction cells, for example. And we have also integrated the process within the string build-up to reduce the number of times we handle the string and so the bracket chains. More than that, due to the fact that it's a fully integrated step, no tuning or waste of time is needed in case you decide to change your string length. Next, please. So not just fine words, but facts. Here is an example of the results achieved in partnership with the CEA and INES, applying the shingling concept to silicon heterojunction cells. Amat performed the string assembly of all the strings with CEA substrates. As you see, the results were amazing, reaching almost 400 watts on a 72 cells equivalence layout. Next, please. Okay, here it's our roadmap, which is to improve the throughput at 6,000 wafer per hour with the flexibility to scale down to cover all the customers, from one with high manufacturing capabilities and requirements to research institute or smaller manufacturing volumes. We are improving the wafer capability up to G12 and thickness capability up to 120 microns, increase and probably lower. Last but not least, we will put all of this feature in a more compact, clean, and space-saving solution. That's all from my side. Thanks, everybody, for listening.
So I also thank you for listening, and I want also to thank here for the financial support from the European Union under the HighLite project. And if you have questions regarding these points here, then please feel to contact Lorenzo or me or Loic regarding the HighLite project. So thanks for listening.
Okay, great. Thanks, Michael. Thanks, Lorenzo. Just one question. There are a couple of questions also in the panel. One from my side. Can you, we know shingling has been also patent restricted in the past. That was also one reason why this very attractive technology that was brought on by SunPower or the companies they bought in the past, actually why it's not being used beyond them. Can you just talk about that, Lorenzo? If somebody buys your tool, how is this with patents? Hello? Lorenzo, I think you're muted. Lorenzo? Michael, can you take that?
Can you?
Sorry, yeah. Can you hear me?
So I can hear you, but I'm afraid I cannot really answer the question. So because we are cutting the cells, we are shingling the cells.
Hello?
Yeah, and
yeah. Lorenzo, can you hear me?
Can you hear me? No, I'm unmuted. Sorry. I think there's a problem. Yes, now yes. Can you hear me?
Okay, yeah, okay. I don't know if you heard my question. The question was on patents, actually. Shingling was always pretty restricted to the market because of SunPower's patents on that, and also Solaria. So how is that actually today if somebody opts for your technological solution?
So as you know, this is a very hot topic. And unfortunately, I cannot reply directly to your question. But what I can fairly say is that we found our own good reason to continue to invest money on this project. And we are talking about quite a lot of money. So word to the wise, as we can say. So okay, patent, it's always a hot.
Okay, but that means, so I think someone who wants to use shingling and buys your...
I think I have troubles with the connection, sorry.
Okay, so but one follow-up question. So if somebody buys your equipment, the company to do modules with shingling, they are safe, patent-wise.
Sorry, can you repeat the connection?
Okay, maybe I asked a question in the chat like the others. So there are many questions in the chat actually also you would want to address, and I think that would be great.
Very bad.
Yeah. Okay, then
I don't know why.
Okay, thanks so much, and we continue. Okay, thanks, Michael. Thanks, Lorenzo.
Okay.